Regular languages and finite automata. What is alphabet? Alphabet is any finite set of symbols. For example, 0, 1, A, B, A, B, C, from 0 to 9, X, Y, Z, any special symbol, plus, minus, multiplication, etc. In short, alphabet means any finite set of symbols. Finite means you can count. For example, if alphabet is 0, 1, then we can count that there are two elements 0 and 1. So this is called as alphabet. If we take alphabet as 0, 1, 2, 3, 4, 5, 6, 7 up to 9, then if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we can count the elements of this alphabet. So this is the finite set of symbols. What is string? Finite sequence of symbols taken from the alphabet. For example, if we take alphabet A, B, then what are the strings? Strings can be A, AB, B, A, triple A and B, etc. What does it mean? String means any type of symbol. String means symbols taken from the alphabet. Here triple A, B is taken from this alphabet. Now, what is language? Language is a set of strings that follow a rule. First is alphabet, then it comes string, and then language. Here we can say that language belongs to string belongs to alphabet. So here language is a set of strings that follow a rule. For example, if we take alphabet as A, B, then we can generate language from this alphabet. For example, if we take language as all strings that end with A, then what we can write? L is equal to AA, BA, CA. Can we write CA? No. Here we have to follow the alphabet AB. We can only use A and B to generate this language. For example, we can take A, BA, double BA, ABA, but we cannot write CA because there is no C in this alphabet. Now let's see about expression. There are many types of expression, such as mathematical expression, Boolean expression or logical expression, relational expression and regular expression. This is what mathematical expression. For example, multiple of 3 can be written as 3n, a plus b. This is also mathematical equation. Boolean expression. Boolean contains and, or, not, like logical expression. Relational expression such as greater than, less than or equal to, plus plus, minus minus, double equal to, triple equal to, etc. Now, what is regular expression? Regular expression is a specific type of expression used to represent language. Previously, we have seen what is language. This is what language is. Now, if we want to represent this language, then we need to use regular expression. For example, if any language says that any combination of A and B followed by A, then how we can write regular expression? This is how we can write regular expression for this language. Any combination of A and B. Any means n number of times. A or B followed by A. If for any language, if there is regular expression exists, then that language is called as regular language. In our example, this is called as regular language because for this language regular expression exists. So what is the definition of regular language? Set of strings that can be described by a regular expression or accepted by a finite automata is called as regular language. Now, what is automata? Here we have seen that regular language is what is regular language? If any set of string, that means if any language accepted by finite automata, then that language is called as regular language. That language is called as regular language, which language is accepted by a finite automata. Then question arises, what is automata? Automata is a machine that process input strings and decides accept or reject. For example, for the above given language, any combination of A and B followed by A, input is string. Rule is must end with A. Output is accept or reject. That means what automata tells? Automata decides that whether the given language will be accepted by the machine or not. Whether the given language will be accepted by automata or will be rejected by automata. Then what is finite automata? Finite automata is a machine with a finite number of states that processes input strings and accepts or rejects them. For example, in our example, this language is a finite automata. Why? Because there are finite number of states exist for this language. If we draw any if we draw automata for this our language, then we can draw like this: q0, q1. Q1 is the accepting state. In our language, it is said that any combination of A and B followed by A, that means automata will accept those strings which will end by the A. So here accepting state is q1, which will accept only A as the ending state, ending alphabet. So if we take A, then it will be accepted. If we take AA, then it will be accepted. If we take BA, then it will be accepted. So here only two states are there. That's why our language is the regular language, because it is accepted by finite automata. Finite automata has finite memory. For example, DFA and NFA. We will see in further videos that what is DFA and what is NFA. Let's see summary of the topics we have studied. First was alphabet, then strings, language, expression, regular language, automata, and finite automata. Let's take one example. Alphabet sigma equal to A comma B. Strings generated from these alphabets are A, B, AB, BA, etc. If we want to generate one language from this alphabet and strings, then we can take one example, that strings ending with A. Now if we want to generate expression from this language, then we can say that any combination of A and B followed by A. This is called as expression. If we want to write regular expression, from this expression, then we can write like A or B star A. See, it follows the language, rule of the language, the strings ending with A. strings ending with A. There can be any number of alphabet before this A. So we can write it like this, A or B star. Whether this language is regular language? Yes. Why? Because we can write regular expression for this language. What can be automata for this language? Machine checking last symbol. This can be automata. Whether this language is finite automata? Yes, because there are only two number of states. That's why it is finite automata. DFA with two states, Q0 and Q1. That's why our language is finite automata. Now, here we need to understand that opposite of finite automata is more powerful machines which has infinite memory. Why? Because finite automata has finite memory. That means it can store limited number of states, limited number of storage. But opposite of finite memory is infinite memory, which has more powerful functionality. That's why opposite of finite automata is more powerful machines which has infinite memories. What are those infinite memory machines? PDA and Turing machine, push down automata and Turing machine. We will see about this PDA and Turing machine in further videos. Now let's see what is the symbols in regular expression. Previously we have seen that we can write regular expression like this for the given language. Now in that regular expression there are many symbols used, plus, star, like this. So here we will see that what are the symbols. Firstly, this star. This star is known as clean star or clean star, whatever you want to pronounce, cleany or clean. Previously we have seen that regular expression A or B star A. Here it is clean star. What it means? Zero or more repetitions. It is also known as clean closure. For example, A star. What it means? A star, zero or more number of A. If we write B star, then what it means? Zero or more number of B. Zero or more number of B. For example, zero means we can write epsilon, then A, double A, triple A, 4 times A, etc. We can also write cleanly star as epsilon into A closure. This is called as positive closure. Plus is known as positive closure and star is known as clean closure. Now, what is clean closure or clean plus? One or more repetition. Clean closure means zero or more repetitions and clean plus means one or more repetitions. If A star can be written as 0 or more number of A, then A plus can be written as 1 or more number of A. Here, strings from clean closures are epsilon, A, double A, triple A, 4 times A. Here, strings from A plus is A, double A, triple A, 4 times A. Here, epsilon will not come for A plus. A plus means clean plus. Now, next symbol used in the regular expression is concatenation. Concatenation means join two patterns in sequence. For example, AB, here A into B can be written as AB. Here this dot is known as concatenation. Here A into B plus C, here concatenation is used. Strings generated can be AB, AC. Why? Because here B plus C means we can take B, either B or C. Here, why? Because B plus C means either we can take B or C. We need to compulsory take A first. So A we can take B or we can take C. So there are only two strings generated from this regular expression. Now next symbol used is phi. Phi represents empty language or empty set. Phi represents empty language or empty set. How it can be written as L equal to phi. Now next symbol is epsilon. Epsilon can be written in three ways. This, lambda, or this. This all three can be called as epsilon. This represents empty string and set can be written like this. So here if we want to write language of epsilon, then it can be written like this. Epsilon allows transition without consuming input. That means if we want to move from state Q0 to Q1 without reading any symbol, without consuming any input symbol, then we can write like this: Q0 epsilon Q1. Now let's see 5 star. What does it mean 5 star? 5 star means epsilon, because 5 means empty language or empty set, and clean star of empty set, that means empty. Empty means epsilon, because zero repetitions are allowed. That's why 5 star equal to epsilon. Now A plus 5 is equal to A. Why? Because 5 means empty set. If we add A to the empty set, then what we will get? A itself.